Hello everyone, welcome to my channel. Today we'll be learning about Advanced CSS Layouts, which is the continuation of the HTML forms and tables. Contents of the presentation are normal flow, positioning elements, floating elements, constructing multi-column layout, approaches to CSS layout, responsive design, and CSS frameworks. Coming to normal flow which refers here to how the browser will normally display block level elements from left to right and from top to bottom. Block level elements: P tag, division tag, H2 tag, UL tag and table tag are each contained on their own line because block level elements begin with a line break. Without styling, two block level elements can't exist on the same line. Block level elements use the normal CSS box model in that they have margins, paddings, background colors and borders. Inline elements. These elements do not form their own blocks but instead are displayed within lines. Normal text in a HTML document is inline, as are elements such as EM tag, that is emphasized text tag, A tag, image tag and span tag. Inline elements line up next to one another horizontally from left to right on the same line. When there isn't enough space left on the line, the content moves to a new line. There are two types of inline elements: replaced inline elements and non-replaced inline elements. In replaced inline elements, these are elements whose content is defined by some external resource such as image tag and the various form elements. Replaced inline elements have a width and height that are defined by the external resource. Non-replaced inline elements, these are elements whose content is defined within the document, which includes all the other inline elements. The width of these elements are defined by their content. The width property is ignored, as such as margin top, margin bottom and height. Positioning elements. It is possible to move an item from its regular position in the normal flow and even move an item outside of the browser viewport, so it is not visible, or to position it so. It is always visible in a fixed position while the rest of the content scrolls. The position property is used to specify the type of positioning. The left, right, top and bottom properties are used to indicate the distance the element will move. Relative positioning. In relative positioning, an element is displayed out of its normal flow position and moved relative to where it would have been placed. The other content around a relatively positioned element remembers the element's old position in the flow. The position element now overlaps other content, that is the P tag element following the figure tag element does not change to accommodate the moved figure. Absolute positioning. When an element is positioned absolutely, it is moved completely from natural flow. Thus, unlike with relative positioning, space is not left for the moved element, as it is no longer in the normal flow. Its position is moved in relation to its container block. The container block is the body tag element. Like with the relative positioning example, the moved block can now overlap content in the overlying normal flow. Fixed position. The fixed position value is used relatively infrequently. It is a type of absolute positioning except that the positioning values are in relation to viewport. Elements with fixed positioning do not move when the user scrolls up or down the page. The fixed positioning is most commonly used to ensure that navigation elements or advertisements are always visible. Floating elements. It is possible to displace an element out of its position in the normal flow via the CSS float property. An element can be floated to the left or floated to the right. When an item is floated, it is moved all the way to the far left or far right of its containing block, and the rest of the content is reflowed around element. The floated block level element must have a width specified. If we don't, then the width will be set to auto, which will mean it implicitly fills the entire width of the containing block, and there thus will be no room available to flow content around the floated item. Here we have an example of floating of an element. We can see that the width is specified of 150px, that is 150 pixels. Notice that a floated block level element must have a width specified. The width is 150px and float is mentioned towards the left. That is, in the top image, the image is at the left corner, and in the below image, the image is floating towards the right. So we have to specify that the float is at the right, margin is at 10px. So there will be a margin and the image will be floating towards the right side with a width of 150 pixels. Floating within a container. It should be reiterated that the floated item moves to the left or right of its container. The containing block is the HTML document itself, so the figure moves to the left or right of the browser window. The floated figure is contained within an article tag element that is indented from the browser's edge. The relevant margins and padding areas are color-coded to help it make clearer for the float interacts with its container. Floating multiple items side by side. One of the most common usages of floats is to place multiple items side by side on the same line. When we float multiple items that are in proximity, each floated item in the container will be nested up beside the previously floated item. All other content in the containing block will flow around all floated elements. Containing floats. Another problem that can occur with floats is when elements is floated within a containing block that contains only floated content. In such case, the containing block essentially disappears. The figured element containing block contains only image and fig caption element, and both of these elements are floated towards the left. Since the figure element contains no normal flow content, it essentially has nothing in it. Hence, it has a content height of 0. To avoid this, a better solution would be to use the overflow property. Overlaying and hiding elements. One of the more common designs with CSS is to place two elements on top of each other or to selectively hide and display elements. Positioning is often used for small design changes such as moving items relative to other elements within a container. In such case, relative positioning is used to create the positioning context for a subsequent positioning move. There are in fact two different ways to hide elements in CSS, using the display property and using the visibility property. The display property takes an item out of the flow. It is as if the element no longer exists. The visibility property just hides the element, but the space for that element remains. While these two properties are often set programmatically via JavaScript, it is also possible to make use of these properties without programming using the hover pseudo class. Constructing multi-column layouts. They are the raw techniques that we can use to create more complex layouts. A typical layout may very well use both positioning and float. Using floats to create columns. Using floats is perhaps the most common way to create columns of content. The first step is to float the content container that will be on the left hand side. Second, using positioning to create columns. Positioning can also be used to create a multi-column layout. Typically, the approach will make use of absolute position. Notice that with positioning, it is easier to construct a source document with content in a more CEO-friendly manner. Approaches to CSS layout. One of the main problems faced by web designers is that size of the screen used to view the page can vary quite a bit. Some users will visit a site on a 21-inch widescreen monitor that can display 1920 into 1080 pixels. Others will visit it on an older iPhone with a 3.5 screen and a resolution of 320 into 480 pixels. Users with large monitor might expect a site to take advantage of the extra size. Users with small monitor will expect the site to scale to the smaller size and still be usable. Satisfying both users can be difficult. The approach for one type of site content might not work as well with the site with another with different content. The two basic approaches to deal with the problems of screen size are fixed and liquid layouts. Fixed layouts. In fixed layout, the basic width of the design is set by the designer, typically corresponding to an ideal width based on a typical monitor resolution. A common width used is something in the 960 to 1000 pixel range, which fits nicely in the common desktop monitor resolution of 1024 x 768. This content can be positioned on the left or the center of the monitor. Fixed layouts are created using pixel units, typically with the content within a division container whose width property has set to some width. Advantage: it is easier to produce and generally has a predictable visual result. It is also optimized for typical desktop monitors. However, as more and more user visits happening via small mobile devices, this advantage might now seem to have some disadvantage. Disadvantages: shrinks below the fixed width. Liquid layout. The second approach to dealing with the problem of multiple screen sizes is to use a liquid layout. In this approach, widths are not specified using pixels but percentage values. CSS are a percentage of the current browser width, so a layout in which all widths are expressed as percentages should adapt to any browser size. Advantages of liquid layouts are it adapts to different browser sizes, so there is neither wasted white spaces nor any need for horizontal scrolling. Disadvantages: liquid layouts can be more difficult to create because some elements such as image having fixed pixel sizes. Responsive design. Problems to a liquid layout is that images and horizontal navigation elements tend to take up a fixed size, and when the browser window shrinks to the size of the mobile browser, liquid layouts can become unusable. In a responsive design, the page responds to changes in the browser size that go beyond the width scaling of a liquid layout. There are 4 key components that make responsive design work. They are liquid layouts, scaling images to viewport size, setting viewports via the tag, customizing the CSS for different viewports using the media. Setting viewports. A key technique in creating responsive layouts makes use of the ability to current mobile browsers to shrink or grow the web page to fit the width of the screen. If you have ever used a modern mobile browser, we may have been surprised to see how the web page was scaled to fit into the small screen of the browser. The way this works is the mobile browser renders the page on a canvas called the viewport. The web page can tell the mobile browser the viewport size to use via the viewport element. Media queries. The other key component of responsive design is CSS media queries. A media query is a way to apply style rules based on medium that is displaying the file. These queries are Boolean expressions and can be added to our CSS files or to the link element to conditionally use a different CSS file based on the capabilities of the device. Contemporary responsive sites will typically provide CSS rules for phone displays first, then tablets, then desktop monitors, an approach called progressive enhancement. As the device grows, we can have CSS rules that take advantage of the larger space. Notice as well that these media queries can be written on CSS file or within the link element. CSS Framework. A CSS framework is a pre-created set of CSS classes or other software tools that make it easier to use or work with CSS. There are 2 main types of CSS frameworks: grid systems and CSS preprocessors. Grid systems. Grid systems make it easier to create multi-column layouts. There are many CSS grid systems. Some of the most popular are Bootstrap, Blueprint, and 960. CSS frameworks provide similar grid features. That is, this 960 framework uses either the 12 or 16 column grid, the Bootstrap uses the 12 column grid, and the Blueprint uses 24 column grid. The grid is constructed using elements with classes defined by the framework. The HTML elements for the rest of your sites are then placed within these elements. Both of these frameworks allow the columns to be nested, making it quite easy to construct the most complex of the layouts. CSS frameworks may reduce your ability to closely control the styling on your page, and conflicts may occur when multiple CSS frameworks are used together. CSS preprocessors. CSS preprocessors are tools that allow the developer to write CSS that takes advantages of programming ideas such as variables, inheritance, calculations, and functions. A CSS preprocessor is a tool that takes code written in some type of preprocessed language and then converts that code into normal CSS. The advantage of CSS preprocessor is that it can provide additional functionalities that are not available in CSS. One of the best ways to see the power of CSS preprocessor is with colors. The background color of the dot box class, the text color in the footer element, the border color of the field set element, and the text color for the placeholder text within the text area element might all be set to the code #796D60. The trouble with regular CSS is that when a change needs to be made, then some type of copy and replace is necessary, which always leaves the possibility that a change might be made to the wrong elements. Similarly, it is common for different site elements to have similar CSS formatting. For instance, different boxes to have the same padding. Again, in normal CSS, one has to use copy and paste to create that uniformity. Thank you. If you like the video, do like, share and subscribe to my channel.